Okay, so MA8A11, question number one. Sandy conducted an experiment with sound waves in dry air at 20 degrees Celsius. She observed that a linear relationship exists between the time and distance that the sound travels under these conditions. She recorded her findings in the table below. Then they give you the table. Based on the information in the table, which of the following is a valid statement about Sandy's recorded findings? So option A is Sandy's data is discrete with a range of x being between 4 and 8. This means x is in between 4 and 8. Sandy's data is continuous with a range of x being between 4 and 8. Sandy's data is discrete with a range of x between 1.372 and 2.744. And Sandy's data is continuous with a range of x being between 1.372 and 2.744. So really what this question is asking you is, do you know what the range is? The range for a given set of data, and do you know the difference between discrete and continuous? Those are very simple concepts to learn. First of all, we can talk about the discrete versus continuous. Discrete basically just means that it is counted. So if I can count something, I can say, for example, there are one, two, three chairs. That would be discrete. It's counted. The continuous is going to be something that has to be measured. So I'm going to have to measure, for example, how tall someone is. If I measure that you are 5'4", that is considered continuous data because you could be 5'4.1" and 5'4.2". So it's always going to be a continual process and opportunity to measure that and get a different number. Whereas discrete, you must count and get that same number every time. So based on that, we're going to now go back and say, okay, now what is the range? Range is simply going to be the highest and the lowest for a data set. Now, which of these should be the range? Is it the time or the distance? Well, that brings in another concept, which is dependent versus independent. A dependent variable means that you need other information to get it. Independent, you don't need, so this comes first. So in other words, the independent variable is required to get the dependent variable. But the independent variable could have come about on its own. So in this problem, you have time in seconds and distance in kilometers. So the interesting thing is that you can almost always know, or time is almost always an independent variable because time moves along regardless of what else is happening on the earth. And time waits for no man, right? So time is going to be the independent variable. And so that leaves distance as a dependent. The independent variable will always be at the bottom. So in other words, it's your x variable. The dependent variable will be your y, because as a result of running over, then I was able to find out my data. So if I have my line, I would run over and then go up. So that's how I would find out what the value of my dependent variable is. So in this case, we said that the independent variable comes first and it's on the bottom, and we also know that time is also on the bottom, which means that by default, distance must be at the top or at the y-axis and therefore be the dependent variable. So the range is the highest and lowest. So just by those words, you know high means up, low means down. So the range, therefore, will be a result of the y's. So the range is going to be the difference in the y's. So this is where you'll find your range. In other words, the distance will be represented by the range. So now I go and I say, okay, well, if we're talking about range and we're talking about distance, then here 4 and 8, 4 between 4 and 8 is referring to time. So that's not right. Between these two, okay, so now we see range. So is it discrete or continuous? Well, we go to distance, and well, these look like you have to measure these. So they're definitely going to be measured, so that's going to be continuous. And obviously it's not discrete because you're not simply counting distance. Number two, an economist is helping a paper company evaluate the demand for reams of paper at different selling prices. The point at which the supply and demand graphs intersect is referred to as market equilibrium. The economists graph the supply and demand equations shown below. And so then they give you the equations, and then they give you the graph. So they've given you a lot of information here. What is the price per ream in dollars of the market equilibrium? So the price per ream. So, okay, well, here's number of reams and here's price per ream. So in other words, they're really just kind of asking us, what is the Y at the intersection? Because the market equilibrium will be where both of these graphs meet. So that's right here. Market equilibrium is right here. So the price per ream, you can see very easily, is at $5. So here, we're just simply going to put 5. We're done. There's nothing else to think about. So all you're doing is going to the intersection and taking the appropriate variable, whether it's the x or the y. For number 3, the flying squirrels glided from 2 different points on the same tree by TE, line segment TE in the diagram below. One squirrel glided from a height of 75 feet and the other from a height of 100 feet. Their gliding paths are represented by RS and EF in the triangles below. Here's your diagram. If triangle RST is similar to triangle EFT, what is the length in feet of line segment ST? So here we see similar. We have triangles that are similar, so yes, we're dealing with similar triangles. And they ultimately ask us for line segment ST. So we want to make sure we know that we are looking for this line segment right here. Line segment ST. But since they said they're similar triangles, and that means that we're probably going to be able to, or have to set up a proportion to solve this. So what are the relationships that we know? Well, it looks as if ST is a base from one triangle. And so then we can see here that TF is a base from the other triangle. And then they also gave us these numbers here. Okay, well, let's see if that's going to be beneficial. It looks like they're basically talking about the back side for both of these triangles. And I can set up a relationship that says that RT, which is this segment here, this segment here, and ET, which is this segment here, should be the same. But the way that we've been practicing is that we say RT over ST, because it's very easy to see that those are from the same triangle. So that's from the small. Should be equal to the same as RT is ET over TF. Now we can plug in what we know. We know that RT, which is the red RT, it gives this line over here and it tells you that that's 75 feet from top to bottom. So even though they didn't write it right here, we can still tell that it's supposed to be 75 feet because of the continuation line. So that's 75 over ST, which we don't know. So we're going to leave that as ST. By the way, this should have been large, equals ET, which is going to be 100 from the given information, over TF, which again is given information, which is 300. So now when we cross multiply, you get 75 times 300 equals 100 times ST. So 75 times 300 equals 22,500, which is equal to 100 ST. And so now, divide both sides by 100. These will cancel, and you get left with 225 being the value of ST. And so that's it. So since they asked us for ST, we are sure 225 equals ST, and so we know we've answered our question. Number 4 looks like a long question, but it's actually really easy. So Anthony used strips of tape to guide him in painting an advertisement on a rectangular shaped store window. The strips of tape are parallel and taped on the glass window. When he writes the message, he wants the letters to be slanted at 65-degree angles. The first word is shown below. What is the measure in degrees of angle 1? So basically, after all of this, you really only need to look at the diagram. They said this angle here was 65 degrees. And this is the idea of a transversal. So if I was to draw one really quickly, anytime you have a straight line, we know that this straight line is supposed to be 180 degrees. Well, if I cut that line right here, then what I know, regardless, is that this angle here and this angle here have to add back up to be 180 degrees. So if I knew what this angle was, by default, I would know what this angle was because it would just be 180 minus that. So really quickly, if I knew that this was 30 degrees, I'm sorry, 130 degrees, then this angle would have to be 180 minus 30 degrees to be 50. Okay. Now, with that understanding in place, if I told you I cut this same line with another line that was at the exact same degree of or slope of the first line, then again I will be creating the same two angles, X and Y. So let's say, for example, that I did this again. I knew that this was 130, so that this was supposed to be 50. And so if I look at it again, if I know that this is 130 and I know that this is 130, if I know that this is 50, then I know that this must be 50 because it was cut with the same line. That's the basic concept of a transversal that we need to understand for this question. So now let's look at what we're doing over here again. So this time when they cut the line, they cut it here and they cut it here. And it is a parallelogram here, so that means that these two red lines are parallel to each other. So that's helpful because now if we know that this is 65, then we can figure this out by doing 180 minus 65, which is going to give you 15. And so if this is 15, then what do we know about this angle here? It must also be 15 degrees because this angle, the right angle, is also 60. I'm sorry. This would be 115. 115 should be 65, and 65 over here. Okay, so Now let's look at this problem one more time for learning purposes without having to see both of these. Same line. Now let's only focus on this angle they gave us. You know, this is 65. So if this is the right angle and this is the left angle that they're asking you about, then you can also now know that to find this, it's the same process. Just simply do 180 minus 65, and again, you should end up with 115 as your answer. So then just bubble in 115. And that's it. Finally, for number 5, the number of portable buildings produced by Chambers Manufacturing last week was 70 on Monday, 60 on Tuesday, 80 on Wednesday, and 50 on Thursday. After production on Friday, the mean number of buildings produced for this week was 67. What is the median number of buildings produced last week by Chambers Manufacturing? This problem is pretty much about experience. And here's how it works. You said again that there was on Monday 70, an additional 60 on Tuesday, an additional 80 on Wednesday, an additional 50 on Thursday. Then after production on Friday, there's another day, which we don't know how much that is. So they say the mean of the building is supposed to be 67. So really what you're supposed to do is find out what Friday is and equate that to the mean, which is going to be 67. Now, how do you find mean? Don't you always take the amount of data pieces that you have and divide that by the number of data pieces? So on Friday, there will be 1, 2, 3, 4, 5 days of information. So instead of dividing by 4, you're going to divide by 5, and that should be 67. So now if you do some cleanup math, 70 plus 60 plus 80 plus 50. So here's 150, 70 plus 80 is 150, 200 plus 60 is 260, but you could always find that using your calculator if you needed to. Should still be over 5 because if everything else comes down, should be equal to 67. Now it's just a two-step equation. So the farthest term from the variable that we're solving for is 5. So we move that 5 first by multiplying both sides by 5. These will cancel. And you get left with 260 plus x equals the result of 67 times 5, which is 335. Subtract 260 from both sides. These will cancel. And I get left with x is 75. Now, we now know that Friday's score was 75 because the mean was 67 and we set an equation to find Friday's score, which was x. Now they ask you what is the median number of buildings. So first we use the mean to find x. We found x, which is Friday's score. And we couldn't find the median until we knew all the scores for all the days. So now that we know that the Friday score was 75, now we can find the median. How do you find the median? Put the numbers in order and find the total number. So there is, and from least to greatest, you have to put them in order, 50, and then 60, and then there's 70. But now the next number is 75 because that's what we just found, and then 80. 1, 2, 3, 4, 5 data points. So the median is supposed to be the number in the middle. So we go from end to end, and the number in the middle is 70. So the median number is actually 70. So I hope this helps. If anything, just go back and replay and replay and replay until you get it. And let's practice and get ready for our quiz that'll be coming up in a little while.